Hey guys, here's a quick video on notes involving molarity, molar concepts, and concentration. So to start off, I want to show you guys probably the best way to take these notes is if you take one note, pull it off to the side of your screen so it goes off to the side, click YouTube, and then you can click here and you can maximize your notes. That way you can have the video of me running in one and you can have the video on, then you can have your notes in the other. So that would probably be the easiest way for you guys to utilize these notes. Now, to start off our Unit 4B, we need to understand a few concepts. The first of those is what a solution is. So we need to know what a solution is in order to understand the unit called solution stoichiometry. So a solution, a good example of it is Kool-Aid. Another example of it would be salt water. Okay, it's a powder or something mixed within something. Okay, so here we have a little figure off to the right. You have some type of powder, which is what's being dissolved, so that is going to be your solute. So the solute is what is being dissolved. Now it doesn't have to be a powder, but usually it is. Okay, so it's what's being dissolved in your solvent. So the solvent's what's doing the dissolving. So it's what's absorbing all of it. So in the case of Kool-Aid, the Kool-Aid powder would be what's being dissolved, or the solute, and the water would be the solvent. Okay, the solution is the final product. It's everything mixed together. That would be your Kool-Aid or your salt water or some type of liquid that has something mixed into it. Okay, so your key terms you need to know: solution, okay, is both of the things mixed together. Solute is the powder, and solvent is the liquid. Okay, so make sure you know those. Those are very essential for the remainder of the unit. Okay, so a key thing for this is concentration. Not the kind like focus. What I'm talking about is the amount of a given substance inside of a solution. Okay, so you have two main types of solutions or concentrations if you're speaking qualitatively. So one is dilute, okay, so that's where it has a low quality solute. So that's where you have something that is more water than it is the solute or the sugar. So if you're comparing this to Kool-Aid, it's very watery Kool-Aid. Okay, so this is the kind that no one really likes. It's very watery, not very dark in color, so it's light in color if the powder is colored. Okay, and then in contrast, you have concentrated solution. So concentrated solution is your very sugary Kool-Aid. Okay, so it has a lot of that solute. Okay, so it's very sugary Kool-Aid, or very salty water. You have a lot of that solute per liters of solvent. Now, it wouldn't be chemistry if you didn't have a unit to measure this. You know, we love our units. So our unit to measure this for this unit is going to be molarity. Molarity is the chemical unit for concentration. Okay, the SI unit. So all that means is the number of moles of solute per liter of solution. Now it's not moles of solute per solvent. Okay, it's moles of solute per liter of the total solution. Okay, so here we have our equation for it. That is something that you are going to need to memorize. You do need to know how to do that. Okay, so our equation, we have number of moles per liters. Very important thing. You must use liters for these calculations, not milliliters. So, important conversion, there are 1,000 milliliters in every 1 liter. So if you ever need to make a conversion between milliliters and liters, this is what you use. Okay, so let's go through some quick examples so that we can understand how to use that equation. Okay, our molarity is equal to moles, the number of moles, per liter of solution. So if we have 2 moles for every 5 liters of solution, what we're going to have is a 0.4 molar solution. Okay, or a solution with a molarity that's equal to 0.4. This is always a capital M is always the unit for molarity. Okay. So that's an easy one. You just take the moles and divide it by the liters. Now you have to be able to solve for anything in this. So any type of any one of the different variables in this equation. Okay, so we have molarity is equal to moles divided by liters. So right here we're looking for moles in this one. So we're looking for our moles. We have 370 milliliters. We have a 2.5 molar solution. So look at here, we notice we are in milliliters. So we need to convert it. So we have 370 milliliters. We know that there are 1,000 milliliters in every 1 liter. So if you go through on that, we have 0.37 liters. Okay, so now we have it in liters. Now to solve for molarity, we just plug it in and solve for it. Molarity, which is 2.5 molar, is equal to the X amount of moles over 0.37 liters, because we always need to do it in liters, never milliliters. So one way to do this, multiply both sides by 0.37. So what that's going to do is 0.37 will cancel out over here, and we have X number of moles equals 0.37 times 2.5. If we multiply those together, we end up getting 0.925 moles. Okay, so that's one way to do these. Another way to do these, and I'm going to show you guys this because it's going to be very important later on, and this might be a less confusing method, is using molarity as a conversion factor. So if you want to use it as a conversion factor, 2.5 molarity is the same thing as 2.5 moles for every 1 liter. So we end up using this as our conversion factor for it. It's very easy to use it like that. So if we want to use it like that, what we want to start off with is we write our liters, what we are given in liters, 0.370 liters, and we make our T-chart. We know that there's 2.5 moles for every 1 liter. We solve for that, our liters cancel out, and we have 0.925 moles. Okay, so our second way to do this is we use our molarity as a conversion factor. And this might be the way that I recommend because it's what we're going to be doing later on is more stoichiometry. So you might be used to this habit from last unit. It might be helpful for you. Now our third one, we have 0.75 molarity, 1.3 moles of iron chloride. And what we're doing is we're looking for liters. So if you want to do it in the equation, our molarity is equal to moles divided by liters. If we have 0.75 moles, we have 0.75 molarity, and we have 1.3 moles over an X number of liters. So if we want to solve for this, we have to cross multiply both sides by X liters. That'll cancel that out. Then you divide both sides by 0.75 molarity. So you end up getting 1.3 moles divided by 0.75 molarity. And we solve and get 1.73 liters of solution. So that's our first way to do it, is using the equation. Our second way is using molarity as a conversion factor. So again, we can do it. We give what we have initially. We have 1.3 moles of FeCl3. Okay, we make our T-chart. We want to use our 0.75 as our conversion factor. So molarity is represented in moles over liters, so that's the same thing as 0.75 moles for every 1 liter. Okay, so we plug that in. 0.75 moles will go on bottom, and our 1 liter will go on top. Solve for that, our moles cancel out, and we end up with 1.73 liters of solution. Okay, if you need any more help or practice with these or someone to run through them, we have help videos right here. You can just click right on that link. It'll help you out with it. Okay, so the last part of these notes is how to affect concentration. So how we could change the concentration of something. You have 4 different options. The first one is increasing the solute. So that's increasing the sugar. So if we add more of that Kool-Aid mix, more of that solute, it becomes more concentrated. So all that means is you add more Kool-Aid mix, it's going to become more sugary. Or if you add more salt, it's going to become more salty. More moles of your solute per liter of solution. Okay, so increasing solute, concentration increases. The second one is decreasing solute. If you decrease solute, concentration decreases. The only way to do that is by adding less Kool-Aid than you had initially. Okay, so if you have less Kool-Aid, it's going to be more dilute. So this is going to be more watery. Okay, so more dilute is more watery. More concentrated, more sugary, or more of whatever that solute is. So Kool-Aid is sugary. Okay. The third one is increasing the solvent. So if you increase the solvent, that's increasing the liquid. Okay, so you're adding more water to a pitcher of Kool-Aid. This would make it more dilute. Okay, so this is going to make it more watery. So whenever we see the word dilute, we think watery. If we're adding more water, it's going to be more watery. It's less concentrated or more dilute. And lastly is decreasing the solvent. Now there are 2 ways you can go about doing this. You can add less water than you did initially, or you can evaporate water from that pitcher. So if you add less water, it's going to have more sugar per liters of that solution. If you evaporate that water, so say you put it on a hot plate and start to boil it, some of that water boils off. So you just have more sugar per liters of water that are present. Okay, so this is going to make it more sugary. Okay, so if you guys have any questions, please let me know. Again, there are help videos right in the middle of this if you're looking for some more practice on molarity.